Assalamu alaikum dear student. I'm your Dr. Hadees shagird. Let's start our topic without consuming our precious time and useless chat. In this lecture, we will discuss about a question that is related to genetics. In this question, we have been asked to find the expected number and the expected frequency of the genotype. Let's solve the question. The question is that find the expected number and expected frequency of individuals if there are 37 homozygous dominant individuals and 24 are heterozygous individuals and 6 are homozygous recessive individuals out of 67 individuals. Okay, first we will make a table like this, and in this table there are types of individuals, three types of individuals. One type, first type is homozygous dominant, another is heterozygous, and third one is homozygous recessive. Okay, first we will write the actual number of genotypes. Actual number of genotypes are given in the question. These numbers are the actual number of genotypes: 37, 24, and 6. The actual number of first genotype is 37, and the actual number of second genotype is 24, and the actual number of third one genotype is 6, and the total number of individuals are 67. Okay, now we will find the actual frequency of the genotype. How we can find the actual frequency of the genotype? If we divide actual number of genotype on total number of individuals, then we can find the actual frequency of the genotype. Like this: 37 divided by 67, that is equal to 0.5522. Okay, the actual frequency of second genotype is 24 divided by 67, that is 0.3582. Okay, the actual frequency of third genotype is 6 divided by 67, that is 0.0895. Okay, now there are two types of genes. One is A gene and other is N gene. A gene is dominant and N gene is recessive. First, we will find the allele frequency of A gene, that is dominant gene. Then we will find the allele frequency of N gene, that is recessive gene. Okay, I am raising the question here. First, we will find the allele frequency of A gene. Allele frequency of A. Okay. How we can find the allele frequency of A gene? If we divide the total number of A gene present in all individuals and divided by all number of genes present in all individuals. If one individual have 2 A genes, then 37 individual will have 37 multiplied by 2 gene. Okay. If one individual of heterozygous genotype have 1 A gene, then 24 individual will have 24 A gene. Okay. Divided by total number of individuals multiplied by 2. It is the total number of genes present in all individuals. Okay, the answer will be 37 multiplied by 2 is equal to 74 plus 24 divided by 67 multiplied by 2 will be 134, that is equal to 74 plus 24 divided by 134 will be equal to 0.73. It is the allele frequency of A gene. Allele frequency of A gene is 0.73. Okay. Now we will find the allele frequency of N gene. Allele frequency of N gene. Okay. Now on the upper side we will write the total number of N genes present in all individuals, and then we will divide on total number of genes present in all individuals. If one individual have 2 genes, 2 N genes, then 6 individual will have 6 multiplied by 2, and one individual of heterozygous have 1 N gene, then 24 individual of heterozygous will have 24 gene. Similarly, divided by the total number of genes present in all number of individuals. If one individual have 2 genes, then 67 individual will have genes. 67 multiplied by 2. Okay. 6 multiplied by 2 will be equal to 12 plus 24 divided with 134. That will be equal to 0.27. Okay. 12 plus 24 divided with 134 will be equal to 0.27. Okay. The allele frequency of N is 0.27. Now we will find the expected number and expected frequency of the individuals by using the equation of Hardy Weinberg equilibrium. According to Hardy Weinberg equilibrium equation, if A is equal to P and N is equal to Q, then according to Hardy Weinberg equilibrium equation, P plus Q is equal to 1, and evaluate this formula. P square plus 2 PQ plus Q square is equal to 1. Put the values of P and Q in this formula. 0.73 whole square plus 2, 0.73 into 0.27 plus 0.27 whole square is equal to 1. Okay. What is the square of 0.73? 0.73 multiplied by 0.73, it will be 0.5329 plus 2 multiplied by 0.73 multiplied by 0.27, that is equal to 0.3942 plus the square of 0.27 will be 0.27 multiplied by 0.27, it will be 0.0729 is equal to 1. Okay. These all three values, 1, 2 and 3, these three values are the expected frequency of the genotype, respected genotypes. Okay. It is the expected frequency of homozygous dominant genotype. It is the expected frequency of heterozygous genotype. It is the frequency of homozygous recessive genotype. Okay. We will add this expected frequency in the table. Okay. Expected frequency of genotype. The expected frequency of genotype of first genotype is 0.5329, and the expected frequency of second genotype is 0.73. 3, 9, 4, 2, and the expected frequency of third genotype is, it is the expected frequency of second genotype, and it is the expected frequency of third genotype is 0.0729. Now we will find the expected frequency of, expected number of genotype. We have been asked to find the expected frequency of genotype, which we have find, and then we have asked to find the expected number of genotype, which we are going to find. Okay, expected number of genotype. How we will find the expected number of genotype? If we multiply the total number of individuals with the expected number of respective genotype, expected frequency of genotype, then we will find the expected number of the genotype. Listen, if we multiply the total number of individuals with the expected frequency of the respected genotype, then we will find the expected number of expected genotypes. Okay, let's multiply it. It is the expected number of first genotype 0.5329 multiplied by 67. That is total number of individual, plus 0.3942 multiplied by 67. Okay, plus 0.0729 multiplied by 67. Okay, is equal to 1 multiplied by 67. Okay, it is rule that if we multiply one number with this side of equation, this side of is equal, then we have to multiply the same number with other side of the equation. Okay, now what are the answer of these numbers? It will be 0.5329 multiplied by 67. That is 35.7 plus 0.3942 multiplied by 67. That is equal to 26.41. Okay, the next 0.0729 multiplied by 67. It will be 4.884 is equal to 67. Okay, these three numbers are the expected number of the genotypes. Okay, it is the expected number of first genotype, it is the expected number of second genotype, it is the expected number of third genotype. Okay, what is the expected number of first genotype is 35.7, and other is 26.1, and other is 4.884. Now we have find the expected frequency of genotype and expected number of genotype. Now compare the expected frequency with the actual frequency and the expected number with the actual number of genotypes. Okay, if expected frequency and actual frequency are equal and expected number and actual number are equal, then Hardy Weinberg equilibrium will satisfy. Okay, this question is an equilibrium if the answers are same, but look at this, answers are not same. The actual number of first genotype is 35.7, but it is the expected number of first genotype is 35.7, and the actual number of genotype is 37 that are not equal to each other. Similarly, the expected number of the second genotype is 26.1 and the actual number is 24. The answers are not matching. Okay. Similarly, the expected number of third genotype is not equal to the actual number of third genotype. And if we compare the frequencies, the here actual frequency is 0.55, but the expected frequency is 0.53. Both are not same. Similarly, if we compare the frequencies of second genotype, then it is the actual frequency of second genotype is 535, but here the expected frequency is 0.39. Frequencies are not matching. Okay. Similarly, the frequency of actual frequency of third genotype is 0.08, but here the expected frequency of the third genotype is 0.08. Here also the frequencies are not matching. It means this is not an equilibrium. The Hardy Weinberg equilibrium is not satisfied here. Okay. If the answers are same according to the actual frequency and the numbers, then it means the equilibrium, Hardy Weinberg equilibrium is satisfied. This whole lecture was about this question, in which we have found the expected number and the expected frequency of the genotype. Okay, I hope you all understand my lectures, and I request you to subscribe my channel and like my videos and share it with your friends.